All right, you guys want to talk me through what you did with number 10 here?
All right, so let's see. So it's a second order homogeneous constant coefficient linear ordinary differential equation. So the standard way to solve that is assume y equals e to the r times your independent variable. So you get y prime equals r e to the rt, and y double prime is r squared to the rt. So then you plug all that in, you can divide through by e to the rt.
Okay, so we plug all that in and we divide, so we get r squared plus 6r plus 13 equals 0.
Right.
I'm just not, so I'm only rewriting this not because I think you've done anything wrong, but just because I'm not sure the recording's catching the annotations.
Right, okay.
Okay, so then where'd you get your roots from?
The quadratic formula.
Okay, you crammed them in the quadratic formula. So you got r is 2i minus 3 and r is minus 2i minus 3.
Right.
Okay, then what'd you do?
So then I plugged that back into our original.
Okay, so you said, okay, so there's like one solution that's like e to the 2i minus 3 times t.
Right.
And there's like another solution that's like e to the minus 2i minus 3 times t.
Mm-hmm.
And so then you put these together with constants on them?
Right, because there has to be some constant a plus some constant b times these that is the solution.
Good. Okay, and then what's the complaint about being here?
You have imaginary numbers in there.
I mean, I prefer to think of them as complex numbers, but yeah. Right. Okay, so there's complex numbers in here, so then you need to, what did you lean on for this?
So what I did was distribute the t.
Oh, you ran this all the way through Euler's instead of just memorizing the solution?
Oh, yeah.
I'd just memorize it if I was you. You're going to use this thing so much. It's going to be a lot easier to just be like, all right, so it's e to the real part and then cosine sine of the imaginary part.
Okay.
But it looks like you got that right here. So you got, in the end, y is a e to the minus 3t cosine 2t plus b e to the minus 3t sine of 2t. And the thing that I see that students sometimes get dorked up here is they'll put the real part in the exponent of the e and they'll put the imaginary part in the exponent of the e and the real part in the cosine sine. It's got to be the I bit goes in the cosine sine and the real bit goes in the e's. And then everything needs a t on it. Or an x, as the case may be. I see that you kind of switched from t's to x's there.
Yeah, I wasn't.
Yeah, so there's a reasonable question. Does that matter here?
Not necessarily. I mean, I guess it doesn't because there isn't one in the original problem.
Yeah, they didn't tell me what y was a function of, so I'm just assuming it's a function of one variable, I guess. Okay, so I think we're good on 10. Any other questions on 10? Okay. So